Welcome to Prescott Central Middle School in Hoopville, Tennessee.
NASA Connect asked us to show you the student activity for this program. Under the guidance of our teachers, Marlon Weaver, Alicia Ray, and Ronnie Manus, we will go through the steps you will use to build the paper scale model of the X33 Advanced Technology Demonstrator. In this activity, we will also measure linear dimensions of the model, compare these dimensions to the actual dimensions of the X33, and compute a scale factor. To help you understand about proportionality and X-planes, go to the NASA Connect website. Mr. Weaver reviewed what the lines and labels on the folding pattern mean, identified the fold lines, cut lines, tabs, and alignment dots. He also talked to us about the parts of the X33 vehicle. Before we begin, here are the materials you will need for the activity: cardstock or heavy paper, pencils, scissors, rulers, glue, and calculators. After you've gotten your materials together, we will begin the activity by constructing the X33 model. Cutting, folding, and assembling the model will take at least one full class period, or about 45 minutes. Begin cutting out the model X33 pattern found on sheet 1. It is important that the cutting and folding of your X33 is accurate so that the parts will fit together and fold into an aerodynamic model. Crease along all the dashed lines, making sure that fold lines and other markings are on the inside. For neater results, place a ruler along the fold line and hold it down tightly. Then slide your finger under the paper and lift it up against the ruler. Cut the 4 slots for canted and vertical fins, being careful not to cut the fold lines. Glue the backside of tab A at the edge which says Glue A here. Repeat for tabs B and C. Start at the nose and tuck the flaps into the front of the X33 and push it in until it stays.
Now you're ready to cut out the canted fins found on pattern sheet 2. Fold each fin in half along the middle and fold back the tabs. Put the glue on the top side of the tabs instead of the bottom before inserting them in the slots. You can close the back of your model in half, but don't glue it yet. Cut out the body flaps and attach them under the back of the X33. Last, cut out the engine, glue it, and attach it to the back of the model. Glue your model closed, and now you are ready for measurements.
Find the measurements of the full-size X33 drawings in your classroom copies, and record them in column B of your Find the Scale Factor worksheet. Each student should fill out the data sheet by determining the corresponding exterior dimensions of the scale model of their X33 and recording them in column C. Write the ratio of the measurements in column D, making sure that the units are the same. Using the results, you can now calculate the scale factor, which is the measurement of the full-size object divided by the measurement of the model. When all the data is calculated and entered in column E, you are ready to find the average scale factor by adding the scale factors in column E and dividing by 3. Record your result in the blank. Now that we understand the concept of proportionality, we're going to test whether the model is a true scale model.
Great job, guys! Hey, let's analyze the data by reviewing the results of the activity and responding to the following questions. What can you learn from building a model that would be difficult to learn otherwise? How can a model be misleading? Pretend the scale factor is 140. Now let's apply this scale factor to a simple problem. Decorate the side of your paper model with the word NASA, like this. Using the scale factor of 140, how tall would the letters be on the X33? Are they bigger than you?